Okay, so I'm going to show you how to get started with Jets by going through the Getting Started guide for jobs here. To do that, let's click on the Getting Started link right here at the top. Then here, you choose the job option, okay? There's a bunch of steps here. We're going to go through all of them, and I'll just cover and kind of explain as I go along here. Next step, install Jets. That's pretty easy. You just gem install Jets. And then here, to configure AWS credentials, I'm not going to go through this because I have video that already explains this, so I'll just link out to that video. But this is the recommended way, I would say, to set up your AWS credentials. You just set up kind of one time here, and it basically the CLI as well as the SDK uses this actually the same credentials. So it's actually pretty nice once you set up. Next step here is a new project. So this is where we actually start writing some code. So this is the meat and potatoes of this right here. So Jet's new demo mode job is the first command we'll run. So let's go ahead and run that here. And what that does is it generates a new starter project using job mode, which just essentially creates a very lightweight project structure, the lightest weight possible. So I'm going to cd in our project now, and then we're going to explore a little bit. The first thing we're going to look at is application config right here. So application config, this is where you set your project name. And this project name is what's used to actually deploy your AWS resources. So whatever your project name is here is basically prefix. It says all the resource names. And then the documentation is just showing that you could actually override each of these settings on an environmental basis. So like Jets env development or Jets env production, you could have different kind of settings. That's what it's just trying to explain there. Next step here is to review the project code. So let's actually take a look at the application code here. Let's go app jobs, application job. And in here, you can see the application job inherits from Jet's job base. And then essentially all your other your job classes should inherit from this application job. And then you can define common settings here, like in this case, class timeout of 60 seconds. Now you should know the current limitation for Lambda function timeouts is 15 minutes. So if your job takes more than 15 minutes, then Lambda might be a great use case for that. Or I guess you could always restart the job after the 15-minute timeout, but it gets a little tricky. Okay? But you should know about the limitation. Next is, let's create a job now. So we're gonna grab this next command, just generate job hard, to generate some more code. So I'm gonna run that. And what that's gonna do is it's gonna create another job here or code. It's called app jobs hard job. So I'm going to open it here. Let's see if that opens right there. There we go. So there is opening right now, or it's open, and you can see in this code there's a class hard job, and there's this rate kind of class method that's being called. It's a macro. You can think about it as macro. What it basically is doing is telling Jets to deploy something called a CloudWatch schedule event, and that CloudWatch schedule event is basically the scheduler, except it's managed by AWS. So usually when you want a job that runs in repeated fashion, you have to like spin up a server and run like cron or something, or like some type of process that's like monitoring and basically always gonna run that job periodically. Well, in this case, AWS has a CloudWatch schedule event service that will manage that server for you, so you don't have to do that. So all you have to do is tell that managed service, I want you to run this job every 10 hours, and it's gonna do that for you. So what this line of code does is going to tell AWS to create that event, I guess the event rule. And I'll show you how this all looks like in the counts and everything in a bit. And then right below that rate, I guess method, there's this perform method here. Now this doesn't have to be called perform. This could be called foo or anything else. But this is essentially translate to a Lambda function. So this Lambda function is connected to this rate method, which is defined right above it, right? And that is basically saying run this perform method every single 10 hours here. And it's basically saying do something with the event. So it's just printing out this basically line here with the event payload. So event is basically a method that's automatically defined, that it gives you access to the event payload that's passed down from whatever is calling this. In this case, the CloudWatch schedule event. So hopefully that all made sense. Once I kind of go through this, it should add clarity to it. So let me see what else is in this documentation. So down here, it's just saying that you can declare basically the schedule expression in different ways, like the cron or rate here. You can also, this is a pretty neat option. You can also use type to basically generate different jobs types with different kind of events. So just supports more than just the schedule event. it supports all these other events here that I'm trying to show you. So the basically type option is going to generate a job for each of those events, which is pretty nice. Next step here is local testing. So it's actually pretty useful to test before you deploy. So let's go ahead and run Jets Console here, and I'll show you how to test locally, okay? So this starts up like an interactive session, essentially. Basically we call it a hard job.perform now. And then the method is perform. So that's the perform method is just whatever this method is called. So if this is called foobar, I would call this foobar here. So you run that, and it basically says do something with events. So see, around our code here. Now the second option is second argument is actually optional, but you could pass it like basically event payload here, which is essentially a hash. Now in Ruby, if the last argument is a hash, you don't have to put these curly brackets around them. Okay, it's just syntactical sugar. Okay, just prettier syntax. But those are different ways you can kind of test there. So I just want to show you how to test locally. So that's how you test locally. Next step is we're going to deploy it, and then we're going to actually be able to test on AWS Lambda. So let's go Jets deploy. So what that's going to do is that's going to bundle up our code into a zip file, and then basically upload to S3 bucket. Then it's going to generate a bunch of basically CloudFormation templates, and then it's going to tell CloudFormation to deploy all these resources that I just kind of covered in detail here. So first thing it's doing is, you can see it's creating the S3 bucket because it needs a bucket to deploy to. So let's go ahead into the console here now, the CloudFormation console, and refresh. We're going to see is creating this first bucket, the first stack, which is demo dev here. And the stack name, the way it works is your project name. And then the second word dev is a shortened name of the Jets environment here, which is development. Okay? And you click on like resources here, and you can see it's creating the bucket here. So this is where it's going to upload the code to now. So once it's kind of done with that, it basically, you can see it's uploading the code. It zips up our code and uploads it to that bucket, and then it updates basically the CloudFormation CloudFormation again in order to deploy this code right here, the hard job. So let's go ahead and refresh this, and you can see it's kind of updating progress. And what it's doing is actually using something called nested stacks. So you're going to see another stack being created here very shortly. There you go. Here's the demo dev hard job stack. This contains basically the code that's going to create the resources I talked about, the CloudWatch schedule event rule, as well as the Lambda function. So you can see it's creating the Lambda function right here. You can see in resources, you can also see events here. So you can see you create the event, the Lambda function first, and then it is creating the event rule. And you can also see the CloudFormation template here. This is all kind of generated for us by Jets. Then you can see resources that are still creating. So it created the Lambda function. Let's see what else it kind of says right here. So how deployment works, basically, what I just said, it zips up your files and then it deploys it via CloudFormation. So now we should review the code and what was deployed. So we've been reviewing the stacks here, but once this is done, it's completed, we're going to look at basically the schedule event, the event rule, and also the Lambda console here. And then we're actually going to do some testing here too, and then we're going to look at the logs. So let's go ahead and let's do all that. It should be almost done here. Let's go here, click refresh. So this schedule event rule is kind of still basically being called, but the Lambda function is done. Let's refresh a couple more times. Let's just go Lambda function for now. And you can see the Lambda function is going to be loading here. And you can see the source code. Okay, refresh because I've deployed before, so it's kind of doing that. So hard job. You can see what it does is actually Jets generates a handler or a shim, and then it actually will route that code to this hard job code that you have. All you have to really care about is your code, because the purpose of this handler shim is to make sure that interface matches with the interface that AWS Lambda expects or requires. And then it can map it to this interface here, which is prettier, which looks more like an active job interface. So what we're going to be able to do is we're going to be able to test this, but let me actually go back here. I'm pretty sure this is done now. See, it's done now. So that is done. We can refresh this too, so it catches up. And then you click on the events rule too. So I want to show you this also, and then we'll go test it. So you can see fixed rate at 10 hours is a scheduled event. So basically, this is the easiest way to find out where the resources are by clicking on what are called the physical ID links right here. And not everything is clickable, but a lot of things are. And it takes you exactly to the console of interest. Here happens to be Amazon Event Bridge, then buses rules here, or else you have to kind of click through. So I think clicking through this is probably the easiest way to get there. And I just want to show you that, again, 10 hours matches with the code here, 10 hours here. Okay. So let's do some testing now on AWS itself. So the test is we're going to click on this test button here in the Lambda. Then we're gonna, it's prompting us for like an event payload. So I'm just naming it test, and then we're gonna give this JSON to it. Save it, and then click on test here. And you can see, basically do something with event, key value, and this is the event payload. Now you can see it right here, so that's pretty convenient. You can also see, I just want to show you under monitoring here, and then you can view it in CloudWatch logs also. Because all Lambda functions, they're gonna write to CloudWatch logs here. So you can always have 10 logs kind of to see. So once this kind of loads up, we're going to be able to see it right here. Okay, you can kind of click on this, and then you can see this is the exact same logs earlier. So I'm going to close that up. So that looks pretty good. So we've reviewed everything here. Next step is to update the project. So we're going to actually make some live code changes. So I'm going to do it all in the browser here. So manual testing is actually very good for learning purposes. So it's great, but once you're kind of ready, you want to codify the process so then you can kind of like deploy it to production in a controlled manner. But for now, we're going to actually do this for learning. And this is equivalent to like making changes on a live server, basically. That's actually what it is. It's kind of interesting. So what we're going to do is here, do something with test event. We're going to change that to like test with event. I think that's what it said here. Yeah, test with event. Okay, cool. And let's go. And then now we can click deploy. And then once that's deployed, we can click on test again. So test. And then you can see that basically it says test with event. Now, another way of testing also is to just change this actually scheduler right here. And I believe that's what docs say, to a very fast rate, like every 1 minute. Click on next, and then click on next, and click on next, next a few times, and then finally update rule. So now what I did was I changed this to a very fast rate. So then we can actually see it running from a trigger coming from the scheduled event. And in the docs, I believe it also says here that we're going to also use just logs. So just logs is pretty cool. Basically what it does is we run this command right here. It's going to -F for follow, N for the kind of name of the essentially Lambda function here. It's basically underscore name and then dash perform the method name here. And then it's going to tail the logs coming from CloudWatch logs actually. So we're going to see the logs from CloudWatch logs you can see right here. So you can see those are all my test ones. And then shortly, in about a minute or so, we're going to see the event coming from the CloudWatch scheduler. And then you're going to see what the event payload looks like from there also. So that takes about a minute or so here. You can see it came through right there. It came through schedule event, source AWS events. You can see. So last thing here is just saying that we should actually update the code and deploy again. So again, it's good to make manual changes for the purpose of learning and debugging. All right. But eventually what you want to do is codify changes, because look, this is out of sync now. So what I'm going to do is actually make code changes up. I'm going to make it slightly different here just so you can see that it got deployed. Do something, I'm going to call this debug with event now. And then I'm going to save that. Control C that the log, and then run just deploy again. Okay. So now we're actually going to deploy and overwrite our manual changes. Okay. So let's see what we did manually here. We made this rule 1 minute, so we expect the deploy to overwrite this and change that to 2 minutes. In this code right here, we changed this to test with event, but we're gonna that's what we did manually. But now we're gonna change it with this deploy to debug with event. That's what I wrote right here. Yes. So you can see kind of the deploy going out. Let's go back here and kind of refresh a couple of times, and you can see updates kind of going out right here. And that's going to take, I don't know, about a minute or so to update everything, maybe 2. It takes a couple minutes. And then once that's updated, let's see what we're supposed to do next here. Update project, and then we're going to delete the project. So let's just kind of wait for this kind of deploy here. And once this is deployed, you're going to kind of see that all our changes or manually changes have been overwritten. And that's, again, why it's kind of important to codify the process. And I'm guessing, yep, this is all done already. So let's go here and click on refresh. This is say now 2 minutes exactly, and then this is going to, let's say refresh this, is gonna say a different line of code. So let's go and wait till that loads, and then you will reload it and it says debug now. See? So it deployed out successfully, and kind of via CloudFormation, it's all controlled. And the last step here is we'll delete the project. So to delete the project, it's just you run jets delete. It's going to prompt us. It's going to say, let's delete the project. Are you sure? Click yes or Y, enter. And then it's going to basically delete first. It actually deletes all our code in the S3 bucket because it needs an empty bucket in order for CloudFormation to delete everything successfully. And then it's going to actually only really delete the parent stack. So that's the neat thing about using a nested CloudFormation templates actually, because all I have to do is delete the parent stack, and then all the child stacks in turn are going to be deleted. So you're going to see all these resources disappearing. And this is also the nice thing about codifying the entire process instead of kind of manually building things, because now when we delete everything, everything is completely clean. We end up back to where exactly we were. So it basically says deleting the event rule is done, is deleting now the Lambda function. So that should be it's complete now. So let's go and refresh here, and this is going to be gone. It's not going to be there anymore. See, the rule failed to get because it's not there. And then the Lambda function is also gone now. So if you can click on functions here, it's all gone. And then let's go look at CloudFormation templates too, and then kind of refresh here, and all the stacks are gone now too. So stacks are gone, and basically back in the terminal. So this is it. So that takes us all the way through the getting started guide for our Jets job project.